everybody, this video today is going to be on lesson 11.3, which is about special parallelograms. This is in page 64 in your packet. So by special parallelograms, I mean rectangles, rhombuses, and squares. Each of these is a parallelogram, but it's a special subset of parallelograms. So we have rectangles. Rectangle is a parallelogram, so all the properties for a parallelogram are also true for a rectangle. So all of these 5 bullet points all describe parallelograms, and they also describe rectangles. So these are not new. The new part are these two. One is that it's a parallelogram with 4 right angles. So anytime you see the 4 right angles there, then you know it is a rectangle. That makes it a rectangle. Another thing is the diagonals are congruent. In this diagram, we're talking about DB is congruent to AC. And this is actually one that plays out quite a bit in things like if you're building something and you want it to be straight, you measure the diagonals to make sure it's actually rectangular, which makes, by straight, I mean it's going to be at right angles. Okay, so using some of this information, let's look at a couple of examples. Well, this one we just talked about. It's wanting to know all the angles. Well, all the angles are 90 degrees. We just talked about that. So each of those is 90. Then this one says that it is a rectangle, so what do we know? Well, here they have an angle. They have a 2x minus 10, and we just said all the angles are 90 degrees. So this must mean that 2x minus 10 is equal to 90. And so then we can just quickly solve this and find out what x is. So we add 10 to both sides, which gives us 100. We divide by 2, and that gives us x is 50. So here x is 50, and 2 times 50 is 100, and 100 minus 10 is 90. So yes, now it is a rectangle. All of these are right angles. All right, and then the last one, we have a rectangle, and we know that this diagonal is y equals 8, and this diagonal is 3y. Well, guess what? I just talked about that. The diagonals are congruent. So now we should be able to say that y plus 8 is equal to 3y. And so if we solve now, we're going to subtract 1y from both sides. And so when we subtract 1y over here, that gives us a 2y. We divide by 2, and we get y equals 4. And so if we plug that back in, that would be 12 here, and that would be 12 here. So they are congruent. That's what we know about rectangles. Let's move on to rhombuses. Okay, a rhombus is also a parallelogram. So again, all these are parallelograms, they're just special kinds. So a rhombus is a parallelogram. So all these same 5 still apply to rhombuses. Plus, there's one more, and that is it has 4 congruent sides. I kind of think of it like a square that's been kind of slanted over. It's a slanted square. Okay, so all of those are congruent. In addition, because this is a rhombus, all of the diagonals are perpendicular to each other. So these all meet at a right angle here. And then finally, the diagonals bisect the angles of the rhombus. So this is getting bisected, meaning 2 congruent parts. This is 2 congruent parts. This is 2 congruent parts. And this is 2 congruent parts. So it's bisecting those angles. Okay, so if we have a rhombus, the first thing that I said a second ago, remember, it's like a square that's been like slid over to the side a little bit. That means all 4 sides are congruent. So that means that 3x is equal to x plus 2. So if we subtract an x from both sides, we get 2x equals 2. So that means x equals 1. We divide by 2, and we get x equals 1. Then this one also is a rhombus. Okay, well, let's look. Okay, so it bisects the angles for 1, but also the diagonals are perpendicular. So an easy one to get would be angle 2. The measure of angle 2 is 90 degrees. If this is a rhombus, which I gotta say, it doesn't really look like a rhombus, but they're saying it is, so we're gonna go with it. If this is a rhombus, then all of these are 90, and all the sides are congruent. So if angle 2 is 90, and this angle is 48, and we have a triangle over here, we can say 90 plus 48 plus angle 1 is equal to 180 degrees. Remember, triangle adds up to 180 degrees. So now I can just solve this. That says angle 1. It looks like a 4. It's an angle 1. If I add this together, I get 138 plus angle 1 is equal to 180. So if I subtract 138 from both sides, then I get angle 1 is 42 degrees. And lastly is a square, and a square has a whole bunch of them. And the reason it has so many is because a square is a parallelogram. So again, those first 5 are opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, same side interior are supplementary, and the diagonals bisect each other. All of those are true. Plus we have a bunch more because a square is also a rectangle. So anything that applies to a rectangle applies to a square. A square is also a rhombus. So anything that applies to a rhombus applies to a square. So a square is a parallelogram with 4 congruent sides and 4 right angles. So a little bit more specific again. The diagonals are congruent. So once again, DB is congruent to AC. Also, for a square, the diagonals are perpendicular, just like they are for a rhombus. And finally, the diagonals bisect the angles of the square. And again, just like they would for a rhombus, they do this also for a square. And then we can think about how that would play out if these have to be 90 degrees on a square. Then if it bisects them, aren't each of these 45? Okay, so just keep that in mind. All right, let's go to the next page and we'll do a couple more examples. Okay, the measure of angle R is here. If it is a square, then it is 90 degrees. Do we have any other angles? Because those are easy. Here's an N. Angle N, that's also 90 degrees. Okay, for a square, the sides are pretty easy on a square also. If this is 5, then everything is 5. So PQ is also 5. QN is also 5. All right, let's take a look at one more. Actually, 2 more. But this one, another square. Squares have 4 congruent sides. If they're congruent, that means they equal each other. So we can set up this equation to where these equal each other. And now we're going to solve. And so we're going to subtract that 3x from both sides. That leaves us with 2x minus 8 is equal to 14. That's a minus 8, so I want to do the opposite. I want to add it. So now I have a 2x equals 22. And if I divide by 2, I get x equals 11. So x equals 11 because that would be 33 plus 14, that's 45. And this would be 55 minus 8, that's also 45. So that 11 works, makes them equal. Okay, lastly, again, one thing that we know is on a square, the diagonals are perpendicular. So the measure of angle 2 is 90 degrees. And then we talked about how the diagonals bisect, right? So that means this was a 90 and now it got cut in half. So the measure of angle 1 is 45 degrees. And then we have these 2 pieces, which, because it is a square, these are congruent to each other. The diagonals bisect each other. So we can just set it up to be x plus 31 is equal to 5x minus 9. I'm going to subtract 1x from both sides. So that gives me 31 equals 4x minus 9. I'm going to add that 9 to both sides. So now I have 40 equals 4x. I'm going to divide by 4, and I get x equals 10. And again, I might just want to go back and make sure it makes sense in my diagram. That's a 10. Up here, 10 plus 31 is 41, and 50 minus 9 is also 41, so it works. X is 10. Okay, that is what we need to know about squares, rhombuses, and rectangles, and we will work on that in class next time.